today's agenda, I'm just going to introduce you to the Oracle 11g caches, and there are actually 2 or 3 of them. And we'll focus mostly on the query result cache today. And as I mentioned, we'll go through a couple of slides to give us a foundation of knowledge, and then we'll turn to some live demonstrations. If we have time, I'll do a quick demonstration on the PL/SQL function result cache, but we may leave that for another day. So, Oracle 11g, new caches. What is new in the Oracle 11g database with respect to caches? First, we have the server results cache. And inside the server result cache, which is in the SGA, and we'll take a better look at that in just a moment in the architecture of it. But we have 2 caches, the SQL query result cache, and let's start just calling that the query result cache for short, and the PL/SQL result cache. They are architected pretty much the same, so once you know one, and I said we're going to focus on the query result cache today, you will probably be pretty comfortable and near ready to use the other. You just need to see the syntax on how to use the PL/SQL result cache. I wanted to mention there's also a client OCI-based results cache as well in 11g. This is an OCI-based database-aware cache, so it's client-side using client memory cache. So I wanted to make sure you knew it was available, but we'll leave that for another day. So new in the shared pool is the server result cache, and you can see from this graphic from the Oracle documentation where the server results cache is, and that is inside the SGA, specifically inside the shared pool. And you can see that there's actually 2 caches inside the shared pool, and that's the the SQL query result cache and the PL/SQL function result cache. Today's focus is the query result cache. What it does is hold result sets. Not queries, not tables, but the result sets from queries. These should be relatively small result sets. It's not meant for millions of rows. You can try, and I have, but it's really meant for small result sets, as we'll see, relatively. When you re-execute the same query or an equivalent query, the database doesn't have any work to do other than to put a latch on the result cache and return the result set to the requesting session. So you'll have a reduction in I/O, reduction in sorts, reduction in computations, reduction in latches, and overall better performance on your database and overall better scalability. As I mentioned, the result cache is not intended for use with large result set. It's really meant for data warehouse and OLAP type queries that are doing aggregations and analytics, typically processing many rows, perhaps hundreds of millions, and returning reasonably just a few. Queries that take a very long time to execute and return few results would be good candidates for this. The result cache is automatically refreshed. And what we mean by that is that Oracle maintains a list of dependents on the results that you've put in the cache and automatically invalidates the results if one of the parent objects, one of the tables, has been updated. So another good practice might be to use this for queries that query read-only or read-mostly tables. It would be bad practice to use this for queries that access tables that are changed very frequently. The new result will be cached upon the next query execution. So if a dependent is updated, if your historical table is updated, what Oracle does automatically for you is marks the result set in the result cache invalid. And the next time a query executes that wants that result, that query has to do the heavy lifting and recreate the result set. So you might think about it as a dynamic, database-aware, memory-only materialized view. And there is actually a connection to materialized views that we'll see in the demonstrations as we go through today's webinar. I mentioned that the query needs to be the same or equivalent to use the cached result. And there's some leeway in that that we'll see as we go through the lesson. But it must produce the same result unless you're using the new feature result cache materialized views, which we'll talk about later. The result must be in the cache, and the result must be marked as published. Published is an attribute of the cache. How does the database know if the same query is being executed? Well, really what the database does is hashes the query text and produces a cache ID or a cache key. And if the key matches a key in the result cache, you use the result associated with the key, as long as the result is marked as published. And as I mentioned, published is an attribute of the result set in the result cache. So you might find that that attribute would go invalid if, for example, the table on which that result is based is updated by another user, or actually the same user. If the subsequent execution of the same query is different, however, in terms of table alias, column list, or column list ordering, the result cache will not match. White space line breaks, however, don't matter. But it would be better, right, if the database were more intelligent regarding query matching, kind of like a materialized view, and kind of like query rewrite is for materialized views. In Release 2 of 11g, and possibly Release 1, but for certain in Release 2, introduces a new query rewrite capability for the result cache called Result Cache Materialized View, or RCMV. And I will demonstrate that to you just a little bit later. How do we configure the server result cache? It's configured with database initialization parameters, and there are 4 of those parameters. The first is result cache mode. The default is manual. You could also set it to force or auto. Manual means that we're going to use hints or an alter session or some other technique to make use of the cache, and I will demonstrate those techniques. And that's probably the preferred setting. Setting result cache mode to force causes every query in your database that isn't against or that isn't violating a restriction of result cache would be cached. And this probably should be avoided. Even the Oracle documentations advise that you avoid this. And I would think it would be a rare database environment that would benefit from force for a database-wide result cache. Auto for result cache mode is actually undocumented, but it can be specified. It does work, if you will. However, we don't really know what it does because as of December, I couldn't find any documentation on this whatsoever. So if anybody out there has found any documentation, please chat it over to me. I'd love to see it. What I suspect this will be in a future release is used for auto SQL tuning caching capability. So if the database recognizes a query through active session history data that could benefit from the cache, it will start using it. Possibly also in effect with the advisors, maybe the SQL tuning advisor or ADDM will recommend caching when it deems it appropriate. The SQL tuning advisor might even generate a profile that includes use of the result cache. The next parameter is result cache max size, and The default is this restricts the size of the cache. Remember, the cache is in your shared pool, so you do want to have a control on how much memory in your shared pool you're dedicating to the cache. The default is less than 1% of the shared pool, but it can be slightly different. Really, it's based on what level of automatic shared memory management you have enabled. In 11g, there is complete auto shared memory management for the SGA, and if you use that, the default is 0.25% of your shared pool. If you're using the 10g automatic SGA memory management, it's 0.5% of the shared pool. If you're explicitly setting your shared pool size and other shared memory management parameters, then it's 1% as a default. Really, I'll demonstrate to you how to begin figuring out how to find the optimal size for your queries and for your databases. And you'll want to set this to a specific size that's best for you. If you set this parameter to 0, you disable the feature. Result cache max result sets a limit on how much one query can consume of the served result cache. The default is 5%. If either of these size limits are exceeded by a query, the cache is loaded until the size limit is exceeded, and then it's marked as invalid, and you can't use it for a subsequent query. And sort of the bummer about that is you know, you've burned some resources to start loading the cache only to exceed the size of one of these parameters. So the DBAs out there that are listening today will want to really do some measuring for the queries that you intend to cache and try to not exceed those limits. Result cache remote expiration deals with queries against remote objects and introduces the concept of permitting stale data into a result. Increasing the value says, yes, I'd rather have potentially stale data rather than checking the remote object every time to determine if the data has changed in the remote object. So it's a trade-off between performance, accessing the remote object, and allowing stale data. There are also several undocumented parameters. For example, _result cache block size. The default of the result cache block size is 1K. Perhaps someone will encounter a situation when you'd want to adjust that. I personally have not, and there are several other undocumented parameters as well. So how do we use the result cache? Let's assume we're going to set the database initialization parameter result cache mode equal to manual, which is recommended. There are really 4 ways to make use of the cache. First is a hint, and you can see the hint specified in your example on your screen now. Select result cache, hint, customer ID and the sum of the sale amount from the orders table. So I'm really looking for customers who have placed orders totaling more than $5,000, and I'm sorting the largest order to the top. The first time I run this query, the results of this query would be cached as long as it's not violating any of our limitations like cache size. The second time I run the query, it would just access the cache, which I'll demonstrate to you. Another way, a second way to use the query result cache is via a table attribute. And you can see alter table customers, and I'm putting the result cache mode to force. And any query against this table, the result would be cached. Now, if it was joined to another table, that table would also have to be in this mode in order for the result to be cached. But in general, you get the idea. Note that Oracle documentation refers to this as result cache annotation. And I just figured I'd note that I would call this a table attribute, but they call it an annotation. So, third way to use the result cache is at the session level, and you can see that would be done with the alter session, set result cache mode equal force, and then your subsequent queries, the results of your subsequent queries would all attempt to be cached. Of course, the fourth way, which I mentioned is not recommended in vast majority of cases, would be instance-wide, and that would be setting your result cache mode parameter equal to force. Okay. 11g also provides us a new supplied package. And that package is called the DBMS result cache package, and it has 6 or so procedures and functions in it listed here. I've made use of flush and memory report status a little bit most often. Bypass is another way to disable the use of the cache at an instance-wide level. Flush flushes the cache, and it's been great for me for testing the cache. Note that alter system flush shared pool does not flush the result cache. Maybe a little bit strange in that it flushes everything else from the shared pool, but not the result cache. So the only way to flush the result cache is with this package, the only way I know how of anyway. Memory report is a package that procedures, that provides insight into the memory used by the feature. I'll demo this to you, but it gives you a good breakdown of what's being used, how much space is being used, and to some extent by what. There are other ways to look at the memory being used, a $$ table, which I'll talk to you about in just a second. Status shows you the status of the result cache either in an enabled or in bypass mode from the use of the bypass function in DBMS result cache package. There are new $$ views available to us here. $$ result cache dependency, and this takes us back to the dependency trail that I mentioned earlier. So here with this, by querying this, we can see what tables we are currently dependent on in the cache. It also or records the relationship between the results and the dependents. Result cache memory, or $$ result cache memory, has a row in it for each and every block in the result cache. And this does provide a more granular look at memory usage than does the DBMS result cache memory procedure. $$ result cache objects. It's very useful because it shows us what objects are in the cache. And there can be two types of objects. One type is a result, and the other is a dependent. Again, we'll take a good look at this. $$ result cache statistics is useful for tuning in addition to the memory report. This shows us how much memory is being used, for what, and creates and finds. It gives us the number of creates, the number of finds, which you might think of as hits and misses. So a good tuning practice would be to discover what is the ratio of creates to finds. Creates would, if the ratio is very high, you may not be trying to cache the right queries. Really, you want to create results and have a lot of hits or finds. So you want the correct ratio there. Some of the tuning tools, like the Quest Spotlight tool, is 11g compliant, and now we'll show you this ratio in a nice graphic. Query result cache restrictions. Like everything in life, we have restrictions and limitations, and one is that you can't have an active transaction. So the current session can't use the cache, can't put something in the cache if there's an active transaction, unless flashback query is used. Results from temporary tables, objects in the system or sys table space, or schemas, cannot be cached, and subquery results cannot be cached. But we want to work around for subqueries for sure, and workarounds would include either creating a view instead of using a subquery and cache the results of the view, or perhaps using subquery factoring, the with clause that was made available in, or was it 9i, I guess. So subquery factoring would allow you to work around that as well. Anything with curval or next val in the query, date time functions, all of these things prevent caching. If you're using PL/SQL result caching, PL/SQL functions would need to be deterministic. So let's go ahead and see how to make the result cache work. I'll do some demonstrations at this point. Okay, first thing I'd like to point out is my environment that I'm working with. I'm connected to an 11g database, and mine is 11.2, so it's a release to 11g database, and that will make a difference as we go through the demonstrations here. I'm running this database in a virtual machine on the computer that you see here. That virtual machine is running Oracle Unbreakable Linux, and I'm connected to it actually through a 10g SQL Plus client. So let's run our first demonstration. First thing we're going to do is to clear the server result cache, so we have a clean slate to work with. And you can see that here. I'm calling the new package DBMS result cache. Procedure is flush. And now I'll run a query to load the result cache. And we can see that this query does include the result cache hint. And it is a simple query that groups by a customer ID and a customer name and comes back with the sum of the sale amount and the number of purchases that the customer has made with us. You can see that the response time is pretty good, sub-second response time. And I just wanted to show you what was in the $$ result cache objects view. So I'm querying that, and you can see that there's a cache ID, which is the key of $$ result cache. Right now, what we're seeing is the type of object is a result, and its status has been published. It's only using one block. The space consumed is 316 bytes, so not very much. I used the cache ID, by the way, that I got previously in this script. So I ran the query again, and we went down to 0.07 of a second, where we started at 3/4 of a second here at the top. So a pretty dramatic difference in response time. Now, I mentioned that the database maintains a dependency trail. So it has this cached result, but if my table, in this case the customers or the orders table, were to change, be updated, the cached result would go from published to invalid. And I just wanted to show you a little bit about the $$ result cache dependency view. So I get the ID from $result cache objects for the dependencies. And you can see that the dependencies have an ID as well, and they're related to an object number. And if you went to the DBA objects view, you could get the name of the object, or more simply, you could just get the name of the objects from $result cache objects, because there's a relationship between these two tables. So you can see that clearly here that there is a dependency trail that is maintained in order to make the cache work. And if either orders table or the customer tables in the Dave schema were updated, then the results would be marked invalid. Another query execution would simply recreate the cache. Okay, and I mentioned you could also go to user objects or DBA objects to get the names of your objects. Let's look at it from a different perspective. Let's look at it from a tracing perspective. I'll use auto trace for today's demonstration. SQL trace would be a little bit better, but we'll just use this for simplicity's sake. So the first thing I did is run a very similar query just to prime the buffer cache, and we see our explain plan, nothing too extraordinary here. We should note the statistics. We're getting about 5,500 logical IOs. You can also see there was 5,500 physical IOs in this particular case, but you know, that might go away. In fairness, that might go away in a subsequent run of the query anyway. But 5,500 logical IOs, as you can see right here, is you know, something we want to take a look at to get the 113 rows back. It took about 0.85 seconds to execute it. So let's cache enable this thing. Same query, but this time I'll use the result cache hint, and we're going to see a difference in the explain plan. There's a new step, result cache, and this step says either you're going to load the cache with results or you're going to use the cache. And the first time we run it, same thing, about 5,500 logical and physical IOs in order to get the 113 rows back. Execute the query again with the /. Notice the elapsed time dropped to 0.06 from 0.85 of a second. Explain plan looks the same as you would expect, and there's the big upside: no physical or logical I/O in order to return the result. Okay, so potentially great scalability. Let's take a little bit deeper look at latches. You know, I discovered through a post by Alex, I've forgotten Alex's last name, apologies, from Pythian Group. I'll give you the URL for his post. I discovered that there were serious problems with release 1 latches resulting from the use of the result cache. So I just wanted to see what was happening with latches. We know latches, reducing latches is really important for scalability and concurrency. So what I did was simply run a PL SQL routine that had a query in it twice and compared the difference using Tom Kite's run stats package. And this will be somewhat revealing. So here's the PL SQL routine. First time I execute it with the result cache hint, and the second time I run it without the result cache hint, and let's see the differences. With the cache, it ran in 14 seconds. Without the cache, it ran in 172 seconds. Actually, that's hundredth of a second. So run 1, the one with the cache, ran at only 8.14% of the time, so a fantastic increase in response time. But what about latches? First, let's look at the cumulative latches. Okay. So not much different in latches. In fact, run 1 with the cache had less latches than did run 2. So that's fantastic. There is a new latch for the result cache. You can see it right here. And of course, in run 1, we had 5 latches on it. In run 2, we had 0 latches on it. I've got a query into the chat. Let me see if I can get this answered here. AutoTrace does not seem to show a difference between storing in result cache and using the result cache. No. Well, in essence, AutoTrace did by virtue of the fact that there was 0 I/O, but it doesn't explicitly show the difference, no. Nor does the explain plan, as that's pretty much obvious. But the fact that the statistics here are showing 0 logical and, of course, 0 physical I/O in order to produce the result, you'd have to scratch your head as to why that could possibly happen, and the only way I can imagine that would happen is the use of the cache. But no, there's no explicit new output in this. I will add to this that there is a little bit of overhead putting something in the cache, and I think one of these demonstrations will show that along the way. So anyway, I hope I've answered that question for you. Okay. Let's take a look at the next. There's a script I'll bypass for today because we're a bit constrained on time. The script is called alex.sql, and we'll just take a look at the script real quick. So if you're on release 1, you want to know about this. Alex works for Pythian Group, and there's the URL for Alex's blog on a test of the result cache in release 1. And in essence, what Alex found was that if he opened a cursor, and the cursor used the result cache, as you see here, and another session on the same database opened that same cursor, that in release 1, the second session would wait, not necessarily indefinitely, but there was definitely conflicts on the result cache latch. It appeared that there was only one and only one latch or NQ that could be taken on that that latch. So this was, a fairly serious problem in release 1. I don't know if they've come up with a patch for this in release 1, but if you are on release 1 and intend to use the cache, you'll want to check it. I duplicated Alex's test in my database. And you see it went from 2 minutes 17 seconds for Alex to run his second sessions query. And I could not reproduce the problem in release 2, and you can see I got sub-second excellent response time using the cache. Okay, let's take a look at the effect of flashback query. So here, what I'm going to show you is the use of the as-of clause to implement flashback query and simply demonstrate that, in fact, it works. So flashback query is supported, and it overcomes the problem of active transaction, the limitation. So the first thing I did was get the current system change number into my procedure, and for kicks, I printed that system change number out. And then I go ahead and do an update on the orders table. and then I select from the orders table. Now normally in the same session we know that this is a limitation. I would not be able to use the result cache. In other words, my result would not be cached from this query. And so I'm going ahead and doing that, but I'm using the as of clause. So as of system change number 2151750. And about a second, 0.14 to execute it and get to 113 rows. And back to that 5,500 or so, 5,600 or so logical IOs and a whole bunch of physical IOs as well. Re-execute the query, and you can see that the response time has dropped from 1.14 seconds to 0.04 seconds, a great indication that we have used the cache. And no logical IOs, no physical IOs to satisfy the to get the result, to satisfy the query. Okay. I also demonstrate here a query from result cache objects. The name is essentially the query that is in the result cache. The type is result or dependency. In this case, it's a result, and the hash cached ID. That's the key that Oracle came up with by hashing this query. Okay, I'd like to jump to this next example. So what I'd like to demonstrate here is how you might benefit from the use of modifying the table attribute result cache mode. Once again, Oracle calls this table result cache annotation. First thing I do is use a create table as command to create a table called T. Now, a couple of interesting things come from this. One is that we're using the CTAS, or create table as command, in order to create a table that is a summary table from my orders table, and I'm creating it with the result cache mode in force. So some ideas out there may be coming to your minds that you may want to create a summary table for some period of time. Unfortunately, temporary tables are not supported, but you may want to create a summary table for some period of time that would satisfy an application need, and any query against that table might be cached. I add a constraint and an index just for good measure on this T table. And now, when I execute a query against the table, even without a hint, the query is cached. So I've turned auto trace on, and I've just done a select count asterisk from T, and we can see that the result cache step is indeed in the execution plan, and the initial response time was very quick. Second response time, not much better, in fact a little bit worse. But once again, the revealing statistics here are no logical or physical IOs in order to satisfy the re-execution of the query. Okay, and a second example, now we're looking at the result cache objects. We can see that there's a dependency out there on Dave.T, and there is select count asterisk from T, which is also in the cache. if I'm going to do a join, both queries would, both tables would have to be in force mode. So what I've done here is alter table customers, put that also into force mode, and then joined the T table to the customers table, and you can see that indeed it was cached. Went from 1371 logical IOs, second execution, 0 logical IOs. There is a no result cache hint. So if you have a table that's in force mode, or surprisingly your database is set to result cache force mode for some reason, you can ask it to not use the result cache. The way to take a table out of result forced mode is to, as shown here, result cache mode default. There's a question in the queue, can you put a temporary table into the result cache? And unfortunately, the answer to that is no. Okay, do one more demonstration for today. And this will introduce the notion of result cache materialized views. So a limitation, other than temporary tables and curval and next val and some other things that I mentioned in the slide presentation, a limitation of result caching is that the query somewhat must be identical. You know, if you change the query significantly in any significant way, it's seen as a different query and will not use a cached result. So we need a way to overcome that limitation, and that's what this demonstration is about. So first, let's look at the limitation. So you can see this query I'm caching. We've seen it before. Just query from my orders table, summing up the sale amount and getting the min and max sale amount and account for my customers. And you can see that the result is cached. Okay. And if I execute what is somewhat of a similar query, which you would think should be able to use this result, and really it could. It's the same query, it just doesn't have the min and the max and the count on it. You can see it hashes to a different value because it's seen as a different query. Okay? And it certainly didn't use the cached result. That was already in the cache. And we can prove this by the existence of the logical and physical I/O in the trace statistics. Okay, I've got a wrong name in my query there in the script, so we'll have to overlook that for now. So Oracle recognizes this limitation and wants to overcome it, and the way they've done that is to introduce result cache materialized views. So what you need to do is execute this new procedure, DBMS advanced rewrite, declare rewrite equivalence, and say, if there's any query that looks similar to this, use the cached result from this query. And you can see the result cache hint being used here. And you can actually give the cache, result cache, a name, which will appear in your data dictionary. Okay, so this gives you the flexibility I think we're looking for. So let's put it to good use. The first thing I need to do, though, is alter my session, just like a materialized view query rewrite, and set stale tolerated attribute. I'm going to flush the cache just to get a clean slate. And now I'm going to execute queries only similar to the source statement. So this query is certainly not exactly like the source statement in any way, shape, or form. I mean, it's missing the sum and the max, but it's still fairly close. And you can see it would be result cached. First time we execute, it's got about 5,700 logical IOs. We execute it again, no logical IOs. So let's take another look at this query. Keep in mind there's no hint in this query. So here yet is another way to make use of the result cache without having to incorporate a hint. So that's nice. Code changes are a hassle, and not having to do code changes might be beneficial. But the bigger upside perhaps in this particular example is the fact that the query does not have to be exactly the same, just like a materialized view. But it's not a physical materialized view. It's a memory-only, database-aware materialized view. So the result that was cached was the result of this query here. And if the orders table were updated and we ran this query again, Oracle would repopulate the cache with the new results. And I've got a bunch of other examples in here with various different changes on the query itself. This one's interesting because there's no group by. Remember the original query. You can see the hash ID is the same, by the way. But you can see the original query back up in the rewrite equivalence package had a group by customer ID. Well, really, we're just asking it to roll up. We don't want a group by customer ID in this particular case, the query that I've just run. So we want to roll up at a higher level. So why not take the result sets that we have out there and just aggregate them? So we do now have a few logical IOs on the first execution, but on the second execution, none whatsoever. Okay. So the first execution went to the result cache that we created previously, rolled up from there, but certainly not 55 or 5,700 logical IOs like we had before. So a great step forward. Okay, so some best practices to summarize query result cache, use of query result cache. Look for queries that process lots of rows, considered expensive, but return only a few rows. Queries that are executed frequently have a limited number of possible bind variable values, because for each different value that you have in a bind variable, it does create a different result in the result cache. Based on read mostly or read only tables, the tables are updated frequently, the cache results will keep being invalidated, and you'll have a bad ratio of creates to finds. Release 1, unless they've patched that or have a patch available for it, limited number of concurrent users. Remember the problem that Alex from Pythian Group found. Release 2, major NQ and latching problems appear to have been resolved. You'll want to monitor your cache, create to find ratio as I mentioned before, memory use, find the size, the amount of memory that you're going to need to cache the queries, or query results that you want, and watch for contention. There also is a PL/SQL function result cache, and this is a shared cache for function results. So it's really a better solution than package-based collections. We, as programmers, we probably passed values around via the package, but this is instance-wide sharing of function results. It does have an automatic refresh, just like the query result cache did, and all you have to do is add one keyword to get great performance. And let's just take a look at the code in this demo. code. This is courtesy of Stephen Feuerstein. So if you're looking for some great information on PL SQL, StephenFeuerstein.com is a fantastic place to go. But you can see here what Stephen is demonstrating here with PL SQL result cache. All you have to do is add one new keyword into the header of your PL SQL functions, and that keyword is highlighted here. It's called result cache. And then subsequent executions of the function aren't executions of the function at all. It's just access to the result cache. So in summary, we have the query result cache, which I look at as a dynamic database or server-side memory-based auto-refreshed materialized view. Very, very powerful feature. The function result cache, instance-wide sharing of function results, also auto-refreshed. And remember, there is an OCI-based client result cache, which I mentioned, but we didn't talk about here today. Okay, so that's it for today. I appreciate you guys attending. If you have any additional 11g questions that you would like to get answered, we'd appreciate if you keep us in mind here at SkillBuilders. We have a series of 11g classes, including a 11g new features class that's available for you. It's out here. All our new 11g classes, including the Oracle 11g new features for administrators, which we offer online or at your facility. So once again, folks, thanks very much for attending today. And if you have any training or consulting needs that you think we can help you with, please give us a call. My email address is dave@skillbuilders.com. Thanks, and we hope to see you in a future webinar.